Assalamualaikum warahmatullahi wabarakatuh. Today we'll be explaining about the technical aspect of safety management, namely hazard recognition, assessment and control. Let's have a look at our team members. First of all, we have Halid Afizi, and then we have Ikram, Afnan, and also me, Izraf. So to start off, let's take a look at what is hazard. So hazard is a potential source of harm, an object, a condition, or a bad workstation. So for example, like a chemical is a hazard, a sharp object is also a hazard. In our example image, the lead container and the flammable solvent is the hazard. Now risk is different. Risk is a chance or potential that the hazard will actually cause injury, illness, or damage, combined with the severity of that potential damage. The common formula is risk equals hazards time exposure. So in our example image, the increased exposure and the resulting increased probability of fire are the risks. Because the container is leaky, it will increase the exposure towards people, causing the probability of an adverse event, which in this case fire, to increase. Understanding the difference is crucial, because the way we manage risks are by dealing with hazards and controlling the exposure. Now that we are crystal clear on the definition of these two words, we can move on to our overview and objective. Our first objective in this presentation today is hazard recognition. So we'll be explaining about how to identify the potential sources of harm in the laboratory and also in the environment. Next is risk assessment. This is the analytical step, where we evaluate the possibility and also the severity that the harm can cause. And lastly, our third objective is control measures. These are the actions that we can take to eliminate or reduce the risk to an acceptable level.
The first hazard recognition based on our survey in the OSH lab is flammable liquids class 1, 2, and 3, such as ethanol, toluene, methanol, and hexane. This hazard has tendency to cause fire and explosion, also toxic vapor, which can lead to harmful effect toward our physical body. In this risk assessment method table, risk score can be calculated through the formula severity times likelihood. The first hazard source, fire and explosion, can make a huge impact, such as multiple fatalities and massive property damage. Flammable liquid has a medium tendency for exposing to source of fire, such as faulty wiring. The risk level of the hazard can be classified as high. Besides that, toxic vapor can make a severe impact related to our health, such as nausea, dizziness, headache, and skin irritation. The common mistakes such as poor ventilation, frequent open container, and improper PPE use will lead to this hazard. And the risk level of the hazard is medium. In this part, the slide presentation shows the diagram of hierarchy control, which is a systematic framework used to manage risk in the workplace, especially in the OSH lab. Hierarchy control can be divided into 5 categories, from the most effective: elimination, substitution, engineering control, administrative control, and the least effective one, PPE. For control measure of flammable liquid in the OSH lab, the most effective elimination suggests us to avoid storing flammable liquids if not needed and substitute experiment using non-flammable solvent when possible. Based on our observation, the OSH lab used the proper certified fire-rated flammable cabinet to store all flammable liquids. The lab assistant will ensure ventilation via cabinet flame arrestor vent in a good condition. And lastly, for our personal safety, we can wear flame-resistant lab coat and safety goggle or face shield. We can also wear chemical-resistant gloves to protect our hand.
Here, I will present the hazard recognition, risk assessment and control measures for the refrigerator that was previously used to store chemical substances. Although the refrigerator looks empty, it still has a strong chemical odor which indicates the presence of volatile compounds and possible surface contamination. Firstly, the main hazard comes from residual volatile organic compounds, or we call as VOCs. These chemicals can remain trapped in the plastic surfaces and insulation, and they continue to release vapors that may cause respiratory irritation, headache, or other long-term health effects. Secondly, we can also identify surface contamination. The stains and residue inside the refrigerator suggest that acids, solvents, oxidizers, or other chemical products were previously stored here. This substance can irritate the skin or even cause corrosive effects. Another hazard is the risk of cross-contamination. If anyone uses this refrigerator for food or biological samples, the chemical residue can easily transfer, creating ingestion or inhalation hazard. The persistent chemical odor is the important exposure indicator. It shows that the refrigerator has poor ventilation and that low-level airborne chemicals may still be present. Lastly, there is a possibility of. In terms of likelihood, the risk of exposure is moderate to high. The odor is still noticeable and chemical residues are still visible. This means that inhalation or skin contact could occur during normal use or cleaning. The severity of the consequences range from moderate to severe, depending on the type of chemicals stored before. This includes skin and eye irritation, breathing difficulties, potential sensitization, and even long-term toxic effects if the chemicals were hazardous. When we combine the likelihood and severity, the overall risk rating is high. This for food storage at all. If the chemicals have already permeated the insulation, replacing the unit is the safest option. Next, engineering controls. The refrigerator should be cleaned and placed in a well-ventilated area to allow VOCs to dissipate. Activated carbon packets can also be placed inside to help absorb remaining vapors. The fridge should be isolated and labeled strictly for chemical storage only. For administrative controls, proper documentation of what chemicals were stored should be recorded if possible. Clear signage should be placed and users must be trained on the risk of VOC exposure and the correct cleaning procedures. Regular odor checks and inspection should also be carried out. Personal protective equipment, or we call as PPE, such as nitrile gloves, safety goggles, and lab coats, should be used during cleaning. If the smell is very strong or the chemical identity is unknown.
First, we can clearly see the corrosion on the cabinet door, which indicate the past chemical leakage or vapor attack. This suggests that acidic or corrosive chemical were either spilled or not handled properly. The second one, there is a chemical residue on the surface. The issue here, we do not know the exact type of chemical type, so there is a risk of irritations or the eye injury if someone touch or disturb the residue. The third one, the corrosion has caused a weakening of the metal structure, including the hinges and also a door framing. This creates a physical hazard because the door may deform or detach, potentially causing the impact or crush injury. For the first hazard, rust and also a corrosive staining, the severity is high because it can cause a chemical burns, eye injury, and even a door collapse if the metal fails. The likelihood is moderate to high due to visible residue and also repeated exposure. Therefore, 4 times 3 is equal to 12, which fall under a category of high risk category. For the second hazard, a stain and also a contaminated surface. The severity is moderate because it may cause the skin irritation or mild toxicity. The likelihood is also moderate because anyone placing item inside the cabinet may accidentally touch the residue. So the score is 3 times 3 is equal to 9, which is a medium risk. For control measure, I apply the hierarchy of control. Starting with the elimination, the best action is to remove the contaminated and the corroded cabinet from the service immediately. Next, substitutions. Replace it with a corrosion-resistant chemical cabinet, such as a polypropylene or a coated steel. Under engineering controls, we actually can install the secondary containment tray and add shelf liners and replace the metal hinges or the component with the corrosion-resistant material. For administrative control, regularly weekly inspections, proper maintenance log, and an early replacement scheduling should be enforced to prevent the same issue in the future. Finally, under a PPE, workers handling the cabinet or cleaning the residue should wear the glove, mask, or respirators and cut-resistant gloves if handling the damaged metal parts. These combined measures reduce both chemical and also a physical risk effectively.
Now, to conclude our presentation, we present to you a maxim: recognize, assess, and control. So, recognize. Recognize hazard is the first step towards safety. After all, we can't manage it if we don't understand it. Now, second, assessment. Risk assessment is to ensure that we can come up with an effective control measure so that we don't waste our time and resources. Which brings me to my third point, which is control must follow the hierarchy. For example, we must always apply the highest level of control we can, such as elimination or substitution. After that, can only we apply the personal protective equipment to ensure that we are safe. And lastly, safety depends on constant practice. Always follow these steps every time you enter the lab or a dangerous working environment to ensure your personal safety and also the safety of the people around you. That's all from us. Thank you.